Hi everyone, today I'm continuing to take a look at question 13 part C of the 2020 North Sydney Boys Extension 2 trial exam. So I've just finished working through part 1 in a separate video, so I'll give a link to that so you can take a look. In this part 2 we're told in the diagram below the interval between 0 and 2 is divided into n equal parts. Find the sum of the area of the shaded region, and then we're kind of given these rectangles that have been kind of overlaid beneath the curve, and I guess we need to work out, okay, how can we work out what the total area of those rectangles would be. So yeah, let's take a look. Again, I've recreated our diagram because it's going to be helpful to overlay our thinking. Now, whilst this question needs us to get a general formula, a general result for the area that the rectangles under this curve will make, because we're dealing with n, this generic n, I think sometimes for questions like this it can be helpful to think of some concrete examples. So to actually pick a value for n, draw up what that would look like, and then see what you get for that actual value, and then see whether that then guides you towards what the pattern might be. And I think what we're going to see with this question is actually the pattern is different depending on whether n is odd or even. And I'm not 100% sure whether the person who wrote this question really appreciated that, because given the marks that are up for grabs, I actually think the amount of work we have to do is quite a lot for kind of the reward we're going to get in terms of the marks. But as you see, I think if we're going to do this question completely and be thorough about it, we do need to think of two cases. First of all, when is n odd and when is it even? So I think what I'll do is I'm going to tackle this in across multiple videos. So first what I'll do is I'll take a look at an example. Let's say n is equal to 4. So that's an example of an even number. It's kind of small enough so it won't be burdensome, but big enough so that we can kind of start to see what's going on. So I'll work through the example n is equal to 4. We'll let n is equal to 4. Then in a follow-up video, I'll kind of work through how we can gauge what the pattern must be for the even cases. And then I'll repeat the process where I'll look at n is equal to 5 for an example of an odd number for n. And then we'll, in a follow-up video to that, extrapolate what the pattern must be for odd numbers. So there's going to be quite a lot of work to do here, but I think, you know, it's not beyond us here. So in terms of, if I want to divide this area into 4 equal bits, so we've got n is equal to 4, well, 2 divided by 4, hopefully you see, it's just a half. So really what I'm doing, and maybe if I just use a different color, we're going to have a line coming up here at a half, and then a line coming up here at 1, and then a line coming up at 1.5, and then in theory a line coming up at 2, but you know that the value of the function is 0 at 2. So it's probably actually worth me noting the function is y is equal to the square root of x bracket 2 minus x. That's the curve that we're dealing with. And then for this part 2, the way the rectangles go is they're staying underneath the curve. So you can actually think of the very first rectangle being from here to here, and it just has a height of 0, so it's kind of, you can't see the rectangle, but technically it's there. And then the next rectangle is from here to here, and then again the next rectangle, actually if I drew that a little bit off, but this is my wonky semicircle, but in theory, because the semicircle is meant to be symmetrical, this really should all be at the same height. So that's just my little kind of hack there. It's quite obvious I'm no good at drawing semicircles. So we'll have this rectangle here, and so we're thinking of the area under that, and then this rectangle here, the area under that, and then again it's just kind of You can think of technically there being a rectangle, it's just got a height of 0. So actually in this case where n is equal to 4, we're only dealing with 2 rectangles really, which is why it's a handy example to look at, because it's not going to be too burdensome to take a look. If we think about the points that we hit the curve on when we drew these lines, we hit the curve here at, well, if we've divided this whole semicircle, this distance from 0 to 2, into 4 equal parts, each of these distances here will be equal to 2 on 4. So they'll all be 2 on 4. And so this point here is whatever the function is at the value 2 on 4, because that's the distance we've gone along. And then again, if we go another 2 on 4 at this point, which actually isn't on a rectangle, and that's something we need to take note of, this would be the value of the function at 4 on 4. And then this would be the value of the function at 6 on 4. And then again, we've got the value at 8 on 4 or 2, but again, we know it's 0. So now if we think about, okay, well, what is the area of these rectangles? Well, the area is going to be equal to the width of the rectangle, which we know is 2 on 4, times the height of the rectangle, which we know is the function at 2 on 4. That's the first rectangle. And then the next rectangle is, again, a width of 2 on 4, times the height, which again is the function at, in this case, 6 on 4. And I guess if we think about it, because it's symmetrical, we know these heights are the same. So really, these are going to end up being the same value. But just for completeness, we'll write 6 on 4. And so in terms of what's happened, we've gone 2 on 4, skipped over 4 on 4, and then 6 on 4. So what I might do is I might actually evaluate this and get an actual value. And then in the next video, when we try and generalize what this result must be in general for any value of n, we can then test out, okay, well, if we substitute 4 into that result, do we get the same value as what we get here? And from an exam taking perspective, that's a handy technique to help yourself independently verify your work, to give you a bit of confidence that you haven't made any mistakes. So this is going to be 2 on 4 times the function is the square root of 2 on 4 times 2 minus 2 on 4. Plus 2 on 4 times the square root, in this case 6 on 4, times 2 minus 6 on 4. And as I mentioned, we know that this is going to be the same, but I'll just work through the mechanics just for completeness. So it's going to be 2 on 4 times the square root, and I'll just get my calculator at this point. So we're going to have 2 on 4 times 2 minus 2 on 4. And now you may notice I'm not simplifying these fractions because I want to keep these numbers, the 2 in the numerators and the 4 being the ends, so that you can kind of see, well, where are the ends throughout this, because it's going to help us when we try and generalize. So 2 on 4 times 2 minus 2 on 4 gets us 3 on 4. And then plus 2 on 4 times the square root. And again, I'm pretty sure this is going to be 3 on 4, but let's just plug it in to check. 6 on 4 times 2, bracket 2 minus 6 on 4. Perfect, 3 on 4. Okay, so this is going to be, we've got 2 lots of, so we've got 2 lots of 2 on 4 times the square root of 3 on the square root of 4, which is 2. So what's that going to get us? These 2's will cancel. So we're going to have 2 on 4 on root 3, or we're just going to end up with the 2 on 4 will simplify to 1 on 2. So we're just going to end up with root 3 on 2.
Panic boom!
So that is the area in the case when n is equal to 4. So that's what we're going to try and hope that we can get when we generalize this result. So what I'll do now is I might end it here for this video. And that way, between the time when you've watched this video and go to my next video, have a think yourself about what is the pattern here and how can we generalize it. And then in the next video, that's what we'll do. We'll try and write this in general terms where we've got just n instead of giving it a value. And remember, that's only half the job done once we do that, because that deals with the even cases, and then we've got to do it all again for the odds. So as I mentioned, quite a lot of work required for this part 2. So all right, I'll see you in the next video.